All right, so now let's try example 4. Example 4, it's a doozy. It's a good one. It's a good one. Are you ready? Get your minds ready.
Is it going to take the whole rest of this page?
Maybe, yes. Oh, it'll definitely take the whole rest of this page. Yes. What? Somebody was asking a question.
It was a fake question.
Oh, it was okay. All right. Okay, so this is typically how U substitution goes. All right, so I'm going to kind of show you, like, okay, if I'm looking at a problem cold, how do I do this? So U substitution, right? So there's no way, is there any way I can manipulate this just using algebra to simplify this expression? No, because you've got a different argument inside the square root, okay? So if I'm going to try to do U substitution, I don't really know where the problem's going. Remember when we did proofs? It's kind of like that, right? I'm just going to start working on it and seeing where it gets me. A lot of times that's how U substitution works, okay? So what's your rule of thumb? If I'm going to choose a U, your U typically needs to be inside a function. So what would U be?
2 minus x.
2 minus x. Kate, what's your question? Yes.
Couldn't you multiply it though? Like you take the square root of x plus 1 squared and you multiply it out and then multiply it times 2 minus x? And it's all under the square root?
I'm sorry, they're not equal to each other.
It's not an equation.
Yeah, they're multiplied together.
It's not an equation. It's not, so I can't just do the same thing to both sides, kind of a thing.
No. Like you take.
I can't like multiply by 2, or I can't
like
square root something.
I mean like do x plus 1 squared and then do that under the square root.
Can't do it.
Those just cancel out when you get the exact same thing.
No, but then if you have it under the square root, you multiply the x plus 1 squared times the 2 minus x.
No.
No.
You should the square root of x plus 1 squared.
Oh, I see what Kate's saying.
Yeah, like that. Cause that's
And
then
then multiply
it by
by
2 minus x.
no, by the square root of 2 minus x.
Well, yeah.
No, because it's all in the same.
Well, if it's on, yeah.
Still have to use U substitution because you still would have an inner function.
Yeah.
Yeah, I mean, so okay, so I'm glad she was saying that because remember proofs. Remember when I talked to y'all about proofs last year and I said there's multiple ways to get to the final answer?
Yeah.
This is one of those things as well. It's very similar. You can do multiple ways to get to the final answer here, okay? I would love to explore that option with you, but I'm going to do this first.
Oh, no,
This-
this looks better.
This might take a really long time. You might get there, okay? But I'm going to show you this way. Yeah. Okay, but I don't want to just disqualify what you're saying because that could be totally valid way of approaching it. And so that was something I wanted to make sure everybody understood is that you can approach it in different ways. Some ways take longer than others. Okay? All right. So if U is 2 minus x, because that's our inner function that we see, our next step is to find du. Okay, so du is negative dx. Okay, so here's the problem. In that other factor, the x plus 1, I have an x, and my dx doesn't have an x in it. Okay, so that's a problem. All right, we can fix it, but it's different than the other ones that we've done. Okay, so what I'm going to do now, and sometimes this helps, I'm going to go ahead and substitute what I know, okay, kind of like an intermediate step, and then see what else I need to substitute. So if I substitute what I know, so I'm going to keep in black everything that I can't substitute. So x plus 1, I don't know what that is, and then the square root of, I know that that's u, right? And then dx is negative du. So I'm going to have a du, and then let's pull the negative out front. So it's kind of an intermediate step. I just want to make sure you're good with all of my substitutions. Yes? Okay, so the problem now is that one single x. Okay, that x is the problem. So what you can actually do is so your goal is to get everything in terms of u. Do you have a relationship that allows you to get x in terms of u?
Yes.
Yes. So you can actually take your u that's in terms of x and solve for x in terms of u. So x would be equal to 2 minus u. And so now when I substitute that in, everything is in terms of u's. Now, this I can simplify because what's underneath the radical is a single variable. So now what I'm going to do is I'm going to clean up that parentheses and get 3 minus u. And then I'm going to rewrite the square root of u as u to the 1/2. And now I can distribute that u to the 1/2 inside. Okay, so you have to be a little clever there. So you can kind of see, so this is one of those types of examples where you may follow what I'm doing in the problem, but then when you get to a problem on your own, there's going to be struggle. I'm just letting you know that right now. There's going to be struggle with u substitution. I remember vividly when I was learning calculus and doing u substitution. And it's just like guess and check a lot of times. Okay? You'll get as you get practice, you'll get better at it. Okay? All right, so now this is in a way that we can integrate. So let's go ahead and integrate. So we have negative out front. I'm going to put the bracket to make sure I distribute my negative. U to the 3/2, and then 3 gets multiplied times 2/3. So we get 2u to the 3/2 minus u to the 5/2 with the 2/5 out front plus c. And so now I'm going to distribute my negative and replace my u. So then I'll get 2/5. I like to lead off with a positive. What was u? 2 minus x.
Can we just leave it like this?
As long as it's in terms of x,
The second
and
one
you have a
is-
plus c on the end, you're good.
Oh, you changed it.
Yeah, I'm a big fan. Questions?
How often are we going to do
Forever and ever.
like
Everything builds. Everything builds. You just gotta get practice.
it's just
Right.
a lot to think about.
It's a lot to think about. It's a lot to think about. All right, here's what we're going to do, guys. We're actually going to, so here's definite integration by substitution. We're actually going to pause on that. I'm going to do that next class, okay, so we can have a break, and it'll be a good review of substitution. So I'm going to break on that, but I do want to do a little bit more of the notes with you. So we're actually going to move, we're going to skip that, we're going to come back to it. And I want you to skip to this section. Okay? They're not, this is not that bad. This is not that bad. I just wanted to kind of ease off a little bit so you can digest just substitution. And then after you've had practice with that, we'll come back on, what day? Wednesday?
Wednesday.
Wednesday? And we'll kind of review and we'll do the definite integration with u substitution. Okay?
Are we doing the quiz first and then finishing this?
Yes.
A-Day got gypped again because we have Legacy on Friday and Pep
Yep.
Rally.
Oh
Yep.
my goodness.
Right.
I
Fun
love
times.
my A-days.
I hate B-Days. A-Days are the best.
Yep. All right. So that is, so just FYI, in the pilot schedule that I had a lot to do with,
That I made and loved BC Calculus.
we're piloting like that kind of thing. So like to hopefully have a schedule that when you have all those PSAT day and Legacy and Pep Rally day, that you're not getting gypped in certain classes than others. So that's part of what I was looking at. So we'll see.
Or are we gonna have like fun days? Like random days?
I'm not saying anymore.
I am.
All right. Okay. So let's pick up.
Is it during second try?
I'm not saying anything.
You don't know when it is?
Oh, I know when it is.
Tell me.
I can't. I'm not allowed to tell you. I'm not allowed to tell you.
The fakest thing I've ever
Okay, all right, let's carry on. So, even and odd functions. So, a review from pre-calc. Even functions, as you can see, are symmetric about the y-axis. Okay, that's the definition of a even function. An odd function is rotationally symmetric about the origin. If you rotate it around 180 degrees, then you get the same function. Okay? All right, so that's geometrically what you're looking at. Algebraically, just as a reminder, so if you're even, then f of x is equal to f of negative x. Okay? And if you're odd, f of x is equal to the negative of f of negative x. It's just the opposite value. Yes? Remember that vaguely? Okay. All right, so if f is even, and if you look down here at the bottom, it says these hold only for symmetric or opposite limits of integration. So if you're going from negative a to a, negative 2 to 2, of an even function, so if we look at this graphically, if this is negative a and this is a, and we find the area under the curve,
0.
it's going to be, that's close, twice
from
the integral from 0 to a of f of x. And the reason that's nice is because of 0, right? Because when you're evaluating at 0, that's just a nice thing to evaluate at. Everybody clear on that?
Almost.
Because this is double the integral, right, from 0 to a. Yes? Okay. Everyone good with that?
Is the next one 0?
Is the next one just 0?
Okay.
The next one's 0. Okay, so in the next one, if you have an odd function, I'm going to look at this one this time. If I go from negative a to a, we have the same amount of area, but one's positive and one's negative. Okay, so in that one's really nice. You don't have to do any calculation. If you know it's odd and you have symmetric or opposite limits of integration, then the integral is just going to be 0. Okay, so let's get some practice with this in example 7. So the value of an integral is given in terms of k, and then find the value of the second integral in terms of k. All right, so this first one we know the integral from 0 to a of that function is equal to k, was the integral from negative a to a. So we need to determine whether this function is odd or even or neither. If it's neither, we'd have to actually calculate it. But so to do that, if it's a function that we're not familiar with, then you would just find what f of negative x is. If it ends up being the same as your function, the function's even. If it's the exact opposite of the function, then it's odd. So we get negative x over, the denominator will still be positive x squared plus 3, so this is the negative f of x. So this is not even. It is odd.
Wait, how do we know it's odd?
You
It's
just
the
have-
negative.
It's the negative of my original function.
Wow.
Right? So like if I restate this here, this is the same thing if I move that negative over.
Because x is squared.
Right? If I move that negative over, whichever statement makes more sense to you. Okay, so then the integral from negative a to a is 0. Oh, goodness.
Beautiful.
Okay. All right, next one.
Why does this one say G of? And the first one didn't.
Right now.
Right, we don't know what g is, and that's fine. Okay, so, yeah, so if we say if f of x equals g of x squared plus 3, that's how you would define that. Okay, so then f of negative x would equal the same thing.
X squared plus.
Correct.
Wait, I'm not following.
Okay, so whatever my integrand is my function. So I just call that f of x. Okay, f of x is just g of x squared plus 3.
Yes.
So then I say, okay, to see if this is odd or even, I want to know what f of negative x is.
So you just put the negative.
So I put negative in there, and just like up here, negative x squared is
Okay.
what x squared plus 3. So since f of x equals f of negative x, this is even. So then the integral from negative a to a of this would be
2K.
2k.
2K 19.
All right, what about c? Let's determine whether this is odd or even.
Oh.
So if I replace x with negative x, we get negative x times sine of negative x. Okay, so sine of negative x is sine, think about the sine function, is sine odd or even?
Even.
Oh, we did this.
No, it's odd.
Odd.
It's odd. This is sine right here. Okay, so sine of negative x is odd, so sine of negative x would equal negative sine of x. Correct? If they're odd. So then this becomes x times sine of x, which is what we started with, so this whole thing is actually even.
Aren't there two definitions for odd? F of x equals negative f of negative x and...
I just wrote them here.
So it's even?
So this thing is even because you had an odd function times an odd function. Okay?
But that thing, the fourth one, isn't that just even?
No,
No.
F of negative x?
equals negative
So
after
it's
that.
2k. It's 2.
So this is 2k. We'll look at it in a second, Chase. All right, D. This one's different. This isn't necessarily an odd or even one. This is just looking back at our properties. This is not an even or odd one because in D, the first one we're looking at f of x, and then this is a shift. Okay, so it's a little bit different. And also we notice we have some wonky things going on with our limits of integration. Okay, this is actually a u substitution one. All right, so in that second piece, what would we let be our u?
8 minus x.
8 minus x. Okay, so if u equals 8 minus x, du would be negative dx. Oh, we don't know how to do this one yet.
Yeah.
We're going to wait. Sorry, because we don't know definite integration. We're going to have to wait on that and example 8. My bad. Okay, so we will come back to that. All right, so your assignment, it's actually kind of a lot because it spans definite and indefinite integration. So you can definitely do the first little bit. So you might want to get started, get practice with u substitution. If you hit a definite integral, then you can just wait on that.
Wait,
Okay.
these are all u substitutions, the 6 practice down here.
Yeah, so if you want to practice in the next 10 minutes on some of these, they're just regular u substitutions. You can practice some of those.
I'm gonna go try and find some more tissues.
Yeah, you can go to the restroom.
Yes. So next class, quiz.
Not this.
It's going to have average value on it. Fundamental theorem of calculus.
1 and 2.
Second fundamental theorem of calculus. But no, and then regular antiderivatives, like indefinite integration, but no substitution. Okay? You're good.